Scatterplots and Correlation, Module 3, Part 3. In this lesson, we'll look more at how to determine whether a linear relation exists between two variables. Prepare a scatterplot for the following data. Determine from your graph whether there is a correlation between the number of hours spent in the mall and the number of dollars spent. Stop the video while you make your scatterplot. There is no apparent correlation between the number of hours spent in the mall and the number of dollars spent in the mall. There is no line rising or falling from left to right across the graph. We can tell this just by eyeballing the data. If we actually plot it and calculate the R value, we see that it is negative 0.262, which is very close to zero, so we have a very weak relationship. The following chart shows the price of gasoline and milk at a local convenience store for a period of 3 weeks. Examine this data for correlations between the price of gasoline and the price of milk. Comment on what a correlation between this data is saying. Stop the video while you make your scatterplot. If we calculate the R value for this data, we see it's very strong at 0.967. So there is a correlation between gasoline price and milk price. Does this mean that the increase in the price of gasoline is causing an increase in the price of milk? No, correlation does not mean causation. This is a good example of two items that happen to have a strong correlation but may not have an effect on each other. Increased fuel prices could have an effect on milk prices, but probably not as dramatic as the one shown here. 3 data points is a pretty small set from which to draw any conclusions. The latter part of this course addresses the effect of sample size on statistics. Draw a scatterplot for the following data about different bird species. Here the data is wing length and wing beat rate. So does the length of the wing have any effect on how many beats the bird has to flap its wings to fly? Stop the video and make your scatterplot. So we would put wing beat rate on the x-axis and wing length rate on the y-axis. There appears to be a negative correlation between wing length and wing beat rate. The more beats per second, the shorter the wingspan. This seems to mesh with our experience if you watch different sized birds in flight. And if we look at the R value, it is negative 0.991, a very strong negative correlation, which means the longer the wingspan, the fewer beats it takes for the bird to stay in flight. Now let's look more closely at explaining the difference between correlation and causation. According to data obtained from the Statistical Abstract of the United States, the correlation between the percentage of the female population with bachelor's degree and the percentage of births to unmarried mothers since 1990 is 0.940, a very strong positive correlation. Does this mean that a higher percentage of females with bachelor's degrees causes a higher percentage of births to unmarried mothers? Certainly not. The correlation exists only because both percentages have been increasing since 1990. It is this relation that causes the high correlation. In general, time series data, which is data collected over time, will have high correlations because each variable is moving in a specific direction over time. Either they're both going up, they're both going down, or one is increasing while the other is decreasing over time. When data are observational, we cannot claim a causal relationship exists between two variables. We can only claim causality when the data are collected through a designed experiment. Many observational studies have shown that there is a strong relationship between smoking and lung cancer, but that is not proof that smoking causes lung cancer. Although it seems unlikely, there could be some lurking variable, some other thing or trait among smokers that accounts for the higher incidence of lung cancer among smokers. It doesn't seem likely, but we can't completely rule out that possibility. It would take a scientific experiment to prove smoking causes cancer. To conduct this experiment, participants who have never smoked would have to be randomly divided into two groups, with one group having to smoke and the other group not being allowed to smoke. After a period of time, lung cancer rates could be determined, and we would have scientific evidence that smoking does or does not cause cancer. You can see that there are ethical difficulties with requiring people to smoke so we can get good data. That is why we have statistics and observational studies. If a bad outcome is suspected, it would be unethical to expose innocent subjects to that risk. Therefore, we observe and collect data from subjects who already have the characteristic we wish to study, and then we look for patterns and relationships. If a researcher misses a lurking variable, which does happen from time to time, incorrect associations can be reported. Now we will look at what a lurking variable is. Another way that two variables can be related, even though there is not a causal relation, is through a lurking variable. A lurking variable is related to both the explanatory and response variables and may not be obvious at first glance. For example, ice cream sales and crime rates have a very high positive correlation. Does this mean that local government should shut down all ice cream shops? Of course not. The lurking variable here is temperature. As air temperatures rise, both ice cream sales and crime rates rise. This problem looks at lurking variables in a bone mineral density study. Because colas tend to replace healthier beverages and colas contain caffeine and phosphoric acid, researchers Catherine L. Tucker and associates wanted to know whether consumption of cola is associated with lower bone mineral density in women. The data shown in Table 3 represent the typical number of cans of soda consumed in a week and the bone mineral density of the femoral neck for a sample of 15 women. The data were collected through a prospective cohort study. Figure 7 shows the scatter diagram of the data. The correlation between the number of colas per week and bone mineral density is negative 0.806, so a pretty strong negative linear relation exists. Can the authors conclude that an increase in the number of colas consumed causes a decrease in bone mineral density? Identify some lurking variables in this study. This study is a prospective cohort study, which is an observational study. Therefore, the researchers cannot claim that increased cola consumption causes a decrease in bone mineral density. Some lurking variables in the study that could confound the results are body mass index, height, smoking, alcohol consumption, calcium intake, and physical activity, as all of these can have an effect on bone density. Warning: correlation does not necessarily mean causation. Just because there is a strong correlation between data, it does not necessarily mean that one set of data is causing the effect that is occurring on the other set of data. During the months of February and March, the weekly number of jars of strawberry jam sold at a local market in New York was recorded. For that same time frame, the number of copies of a popular classical music CD sold in Florida was recorded. The data was examined and was plotted. From looking at the graph, it can be seen that there is a high positive correlation between these two sets of data. So, this must mean that the number of jars of strawberry jam sold in New York was causing an increase in the number of classical music CDs sold in Florida. Of course, this is not true. Always be careful what you infer from your statistical analyses. Be sure the relationship makes sense. Also keep in mind that other factors may be involved in a cause-effect relationship. Now take Module 3, Part 3, Assessment of Learning. The password is linear and all lowercase.